Now this is where we ended off last time, right? We were talking about how there's also the value in having, we name our variables with good names so it helps us understand what the data is. And if another programmer looks at your code, they can go, oh, well, judging from that variable name, I have an idea of what that data means. Where if you just have a variable that's like A equals 421, someone's going to think, well, what is that? Like, what does that mean? It's the same idea with functions. If you've got a good function name, sure, you might think like, okay, well, the calculation for converting Celsius to Fahrenheit, did that really warrant its own function? Okay, that's a valid question, I suppose, but you know what's a lot clearer is if you see a line of code that says Celsius to Fahrenheit, then you know it's a function call, versus C times 9/5 plus 32. Right? Celsius to Fahrenheit is quite obvious about what the functionality is doing there, where if I just look at that line of math, if I didn't remember that whole 9/5 plus 32 thing, I'm going to look at that line and be like, what does that mean? Why is that an important thing? So the function name also gives a really good, nice, clear way to name functionality. Now, we'll start with, this activity here. Just write your own function to do something with math. I don't care. You can add two numbers and multiply it by a third number and then divide. I don't care. Whatever. It doesn't matter. Just write a function and get it working on Colab. And if you're stuck on where to start, use the Celsius to Fahrenheit example I have above as a jumping off point. Right? You can add more parameters if you like. You can change what the calculations are doing. Do whatever you want. I don't care. Just make a function. Remember, wear your masks. And I don't mean little chin things. I mean put them on. Of course, once you write it, also call it. I realize I didn't mention that in the activity, but also call it to see if you get it working. Raise your hand if you've got something working. Raise your hand if you will, if you have like one more minute. Okay, I'll give you a minute. In the meantime, does anyone have any questions? So I mean, the way I do this, copy this, paste it here. And all I've done is I just changed the name, changed the parameters I gave it before, because why not? And so I just did one. It's a silly function, right? All I did is I copy and paste. I started by literally copying and pasting the Celsius to Fahrenheit example. First, I changed its name to my function. I then gave it 4 parameters, A, B, C, D. Not great variable names, but. And then I took A and B, added them together, and stored it in a new variable called X. Took the difference between C and D, stored it in a Y. Did the division of X and Y, so the A plus B divided by C minus D. Put it in Z, then I returned Z. That's it. Why did I make the function this way? Because I did. It's entirely arbitrary. What's in the function doesn't matter here. It's a silly example. The return Z is important because there's something called scope, which we'll be talking about a little later further down this topic, where if a variable is defined inside the function, it only exists inside that function. So, I mean, after running it with 1, 2, 3, 4, within the function, my function, the variable Z is storing the value -3, -3.0. It's a float. The trouble is that Z, I can't access that Z from outside the function. If I did something like, if afterward I did print Z, and you think, okay, well, I'll just take whatever was in Z and I hit run, it's going to say Z is not defined. It's not defined because it only exists inside my function. It's defined inside my function, but elsewhere it's not. So the return is a way to say, okay, the value of Z in this case, when you're finished, when you function, when you're done doing what you're doing, you're going to take that value and give it back to wherever you were called. So let me show you. So I run this, great. So what will happen is, my function gets called, it goes up here, does all that calculation, and then finally, Z, which is -3.0, Z, which stores -3.0, we return that value to where it was called, which is line 7. So after that function is done completing, we're like replacing it with what it's returned. So that whole line ends up being result equals -3.0. And then of course I can print out result, -3.0. We'll talk more about scope in a couple moments. But return is very important there. As with the parameters are the fancy word, it's a fancy word we use to mean the variables that we're giving to the function, right? We provide values, we call them arguments, the values we give to the function. So that would be the example of the 1, 2, 3, 4 there. I'm providing the function with 1, 2, 3, 4. When the function starts, A equals, guess what? Who wants to take a wild guess of what A is going to be equal to when it's called on line 7? 1. Why? It's the matching game. A is the first variable or parameter, and 1 was the first number. What variable do you think 2 is going to go into? Or parameter. B. What about the 3? And of course, D will be 4. If it was any more complex than that, computer scientists wouldn't be able to do it. Computer scientists are stupid. If you want to be good at this, stop thinking so much. I know this sounds ridiculous, but it's so true. Most of the time, when people who are good students, they're doing everything they're supposed to be doing, but they're just not getting it, chances are you're working too hard. You're looking to connect dots that don't exist. You're looking for patterns that don't exist. The simplest approach is best here, is what does the code say? Don't make any assumptions about it. What does it say? Keep things simple. Never make anything complicated. Computer scientists will be mad at you because we can't do it. So the parameters here, A, B, C, D, they allow us to provide specific values to the function in order for calculating what we want based on the values we want to give it. It's kind of hard to motivate with this silly little example, but if we go back to the Celsius to Fahrenheit example, I gave it the parameter. That function had the parameter temp in Celsius. Right? We go back up here. Temp in Celsius is the parameter I gave it. And if I call it with the value 20, that means temp in Celsius is a variable, it's the parameter. It's the variable holding the value 20. It allows me to pass information to the function from where the function is called. Same thing with here. This is the function definition. This is an example of me calling the function. And when I called it here, I gave that function the values 1, 2, 3, 4. If we go back to copy this. If you ever get into a case where you hit run and it's like, it's not defined, but it's right here, chances are you just need to run the cell first and then run this one. Okay. Oh, and then I guess print out. Okay, 68. I wanted to calculate what is 20 degrees Celsius to 68. Now if I want to know what 30 degrees Celsius is, I just change it to a 30 and hit run. Great, it's 83. What about 3 degrees? Oh, 37.4. It allows me to specify the value I actually want to run that function with. We want our functions to be general. What I mean is, imagine you ended up writing, instead of writing it with a parameter, you came along and wrote a function called 20 degrees Celsius to Fahrenheit that looked like this. It's a function that doesn't take a parameter, and it just calculates what 20 degrees Celsius is in Fahrenheit. That's a rather useless function, isn't it? Because all it will ever do is tell you what 20 degrees Celsius is in Fahrenheit. Why even have a function for that? Just calculate it yourself and save it to a variable. It's not very helpful. So that's why we give it a parameter, so it can be more general purpose. Because let's say here, you've got the function 20 degrees Celsius to Fahrenheit, and I say, okay, now tell me what 30 degrees Celsius in Fahrenheit is. Are you going to write another function called 30 degrees Celsius to Fahrenheit? No, that's silly. We make our functions more general with parameters. Just like we saw with f of x, just like in math. That x is the parameter. We can specify f of x equals x plus 1, so just what's 1 more than x? And if I ask you what's f of 7, you say it's 8. What's f of 21, you say it's 22. It gives us the flexibility to specify what we want it to be calculated on. In other words, don't do this. This is silly. The alternative is call it with the parameters. Before, when I was saying arguments, parameters, when you call the function with a value, we call that the arguments. Within the function, when we talk about like the variables that exist within the function, for example, the temp to Celsius, we call them the parameter. It's just jargon. If you mix this up, no one's going to get mad at you. I mix them up all the time as well. Just an interesting little piece of jargon. Any questions about the idea of parameters there? Yes? could, but we actually, input's not a great thing to use. We use input for caddis. That's going to be like the only time we use input in this class, aside, I guess aside for the exercises from the textbook. We don't like input for the functionality. If we really wanted to do input, what we would typically want to do is do the input outside the function, then take the value that was inputted and call the function with that argument. We don't really want to put the inputs inside the function because that's a recipe to start introducing problems. We want our functions to be like, this calculates Celsius to Fahrenheit. And you might say, but why don't I just throw the input into that function? And you're right, you could. There's nothing stopping you from doing that, but then you're kind of like disturbing the single purposeness of that function. Right? It's a general function in the sense that we can specify the Celsius value, but suddenly that function's starting to do a lot of different things. So there's nothing wrong with it other than, well, it's kind of maybe bad design. Learning what's good design, it's something you're going to be learning over your careers. If you did like something like that on an assignment where it was ambiguous on what to do, no one's going to be mad at you because, yeah, you're just starting out, you're just learning. You wouldn't know that that's bad design. It's something you're going to learn over decades type thing. Presumably if you keep doing it. Other questions about that? That was a good question though, because where do you know when to do that? And yeah, if we wanted the input, it would be like, what I mean is out here. There. So now I can specify 50 degrees Fahrenheit is 122 Celsius. Great. That would be the way to do it. Put the input outside the function and pass it as a parameter. The less good way to do it is to not have the parameter and do the input in here. That's what you were asking effectively, right?
Yes.
Okay, cool. Cool. Good question though. Other questions? All right. Okay. Now, when talking about parameters, I know I talked about this yesterday. If you're not happy with it, if you're uncomfortable with it, well, you've been using this before since however old you are when you start learning about functions like f of x. You've seen it before. In fact, here's f of x equals x times 9/5 plus 32. That's the Celsius to Fahrenheit conversion. It's just written with the math syntax you're used to. I've defined the function as f of x. Now, if you want to call the function where f of 20, like what is f of 20? Well, you would just replace the x's with the 20s and then do the calculations. That x is the parameter there. So it's the same thing. It's just with what I had, it was in Python syntax, where this is more the math syntax you've seen before. Yeah. So execution of a function. How is it going to work? Here's an example of another function called square of sum. What is it going to do? Well, it takes two parameters, a and b, it calculates their sum, it then multiplies c by itself, squaring it, and then return d. So it's calculating the square of the sum of two arguments. Great. So if I call, so remember, this is the definition. If I call it with the arguments 2, 3, here's how Python is going to do it. First, it's going to say, okay, do I know of a function called square of sum? It needs to be able to know what you're asking it to do in the first place. Yes, it does. We just defined it. Great. So it takes the values supplied, the arguments, the 2 and 3, and replaces. It puts them. It assigns that value to their respective parameters, a and b. First one goes to the first one, second one goes to the second one, third one goes to the third one, fourth one goes to the fourth one, and so on and so on and so on, based on however many parameters you have. Here it's only 2. So after, right at the start, it goes, okay, great, I'm going to start running a, b. Well, what is that? Okay, a is 2, b is 3. It's just assigning them as if they're variables that are just in the function. The sum of a and b is calculated and put into the variable c. Okay, a, b put the result into C. The variable C is multiplied with itself, effectively squaring it, right? So C times C is C squared. And the result is assigned to a variable D, and then we return D. And then we're done. The function's done execution, it stops running, it's done, it's happy. Once it's done calculating it, that return means, okay, the value that you just calculated, here you go. The function does the calculation and gives it back to you on the line of code that it was called. If you happen to provide too few parameters or too many, Python will let you know. And it'll give you a pretty helpful error message saying, missing one required positional argument. Takes two positional, but 3 was given, right? So that was an example of if I gave it only 1 instead of 2, or 3 instead of 2. If I gave it 4 instead of 2, I bet you it would say, takes 2, but 4 were given. It's a pretty helpful error message. Okay, return. Now I'm going to warn you. This return idea is typically one of the ideas, one of the new things we learn that new programmers, students in your position, tend to struggle with. And I understand why, and part of the reason for it is how Colab is helpful. But we'll work through it and we'll try to make sure everything's clear. When a function returns a value, it's just giving it back to whoever called it. So in this example, after calculating the Celsius to Fahrenheit, this function does the calculation, then it returns the value stored in here, which in this particular example where I gave it 50, the result was 122. That value, 122, is returned to the line where it was called. So the line where the function was called was line 2 in this cell. Meaning, this whole chunk right here, this whole function call, is effectively replaced with the value 122. And then what are we doing with the result of that, 122? We're storing it in the variable called Fahrenheit. Next line, print it out. So return is a way to, parameters and arguments are a way to provide information to the function so it can do what it needs to do. And then the return value is what it gives you back once it's done. Programs almost always, that's not true. A lot of programs take input, do their thing, produce output. The return is the output. Now, the place where people tend to get confused is, but print gives me the output. No, it doesn't. Print is displaying some value to the screen, but it didn't actually return anything. I've got an example of this as we go, so sit tight. So every function you call returns a value. Even if you don't write that return statement, Python adds one for you, you just don't see it, and by default it returns a special value called none. It's a whole new type. It's none type, and it can only ever take on one value, the value none. And it's just kind of like a flag value that programmers use. We're going to learn all about that in a couple of weeks, let's say. So we wrote return at the end of the previous function, right? This one, and also with the Celsius to Fahrenheit. This allows me to specify the value being returned by the function. Consider the following example. Here the function calls Celsius to Fahrenheit with the argument 20. And it's going to execute the function. When the function finishes, it returns the value 68 because that's what the result is. And the value 68 is stored in the variable temperature because Celsius to Fahrenheit with the parameter 20 returns 68. And then I've got the 68 floating around. I need to do something with it while I'm assigning it to the variable temperature on line 1 there. Line 2, I say print out the temperature, which happens to be 68. And yeah, if you don't return something, the function will still return a value, but the value will be none. None is a special type. There. Okay, I'm going to give you a couple minutes to work on this activity. Do this activity. This is a good one because this will hopefully make clear where a little confusion about return can happen. So I'll give you a couple minutes to do it. The first part is the easy part. It's basically take the Celsius to Fahrenheit function and do exactly what I'm about to do. So I've got Celsius to Fahrenheit. I'm going to write another function immediately below it. So it's called print Celsius to Fahrenheit. And instead of a return, I do that instead. Okay? They're nearly identical with the exception of the name and how the last line doesn't print or doesn't return something, it prints something. So that's what I want you to start. And then I want you to try these 4 different things. Take your time and make sure the results, the output you get, what you see, makes sense. Is that okay still? The first one I tell you to run is probably the weirdest of the 4. Who here ran the first one so far? Hand up really high. Second one? Third one? 4, okay, well, I'll stop after explaining the first one. You can carry on. The first one's funny because it seemingly produces 2 lines that we can see here. 68.0 and then none. Well, there are 2 print functions called, or there's one print function called twice. One is inside the function print Celsius to Fahrenheit, and the other is print whatever the result of this is. This function, print Celsius to Fahrenheit, does not have a return statement in it. Which means, great, the default return statement that you don't actually have to write will be thrown in there by Python. And that function returns, if you don't specify anything, that function returns the very special value called none. And it just means that, well, something had to be returned, so I'm going to give you this box that just, it's a very special box that can only mean one thing. It means that there's nothing there. So it's a value that means nothing. Which is kind of a funny idea, but you're going to get so used to using this and be so glad it exists shortly. None is its own type. If you type out what's the type of none, it'll say none type. And it's an interesting type because it can actually only ever take on one value. Something of type none type can only ever have the value none. That's all. It has like a unary value. Integers, right, they could take on 1, 2, 3, -4, 17, 28. They could take on a lot of different values. But none type is a little different. So the reason we see none printed out is I said, okay, we see 68 because we call the function print Celsius to Fahrenheit. We jump up to line 7, assign the value to temp and Celsius, do the calculation, return, or pardon me, not return. Print out 68. That's what we see right here. Function is done, and there's no return, meaning it magically returns the super special value called none. So, after this function is done running, it's effectively replaced with none. And when you print out none, Python just says none. That's all. That's all it's doing. All right, carry on and keep running the subsequent ones and try to figure it out. The first one's the trickiest one. Raise your hand if you're done all 4. Raise your hand if you will be in like 10 more seconds. Okay. I'll start explaining the second one. This is what we were already used to. When we run this line, print, call the function Celsius to Fahrenheit, we only see one value printed out, the 68.0. And the reason for that is we call the function 68 or Celsius to Fahrenheit on 20. We go up here, run this function, and then we return the value of temp in Fahrenheit, which in the case when temp in Celsius is 20, Fahrenheit is going to be 68.0. That value is returned. It is not printed out inside that function at all. All it does is get returned. That means this function call is effectively replaced with 68.0. And then, well, we're saying print out that value. So that's why we only see 68.0. If we call print Celsius to Fahrenheit, the function print Celsius to Fahrenheit, not the function print calling the function Celsius to Fahrenheit, we see 68.0. And that's it. Because we call print Celsius to Fahrenheit, do the calculation, and then we print out temp in Fahrenheit, which is 68.0. The function's done, it goes to the calling function, it returns none, but we're not doing anything with the none. So Python doesn't do anything there. The reason it said none before was because we said print Celsius to Fahrenheit. But if there's just a none value, if this function doesn't return anything, it's just, there's nothing there more to do. That's it, it's done. Now, the last one, which is this, is lying to you. Colab is lying. Because at no point did I write print. I called Celsius to Fahrenheit, there's no print in here. And then on this line of code, I never said to print out the result, but Colab is seemingly printing out the result. It's lying to you. Colab is being nice and just telling you, oh, this function returned a value, and you didn't do anything with it, so here. And it just displays it. But it didn't actually print it out. We can be even more clear. If I have, and I say print ASD, we see the string hello. If I don't, if I just say, hey, ASD, I'm just saying ASD, and then I'm not doing anything with that value. When I use that variable like that, it's kind of the same idea of like, oh, here's the value, and you've done nothing with it, so here. If I do this, we see hello. But you'll notice it actually looks different. And it looks different because, yeah, it never actually printed anything out. It looks like it did, but there was no print here. It's not obvious with integers or floats, but it becomes more obvious with strings because when you do it like this, where Python, or not Python, where Colab just kind of displays the value that was dangling around, it's got the quotes. Where when I had the print around it, it doesn't include the quotes. So with the strings, it's slightly more obvious that it's not doing the same thing. But with integers and floats, it might mislead you to think that, oh, return is basically doing the same thing as print. No, it is not. It absolutely is not. Even though it looks like it is. This is where people get confused. If I were to then have another line of code that said print nothing, no, let's print ASD, print, we'll see that the 68.0 doesn't get displayed anymore. That's because it'll only ever display that dangling value if it's on that last line of code that was run. So line 1 in the cell had the dangling value, and then Python just moved on and did print ASD, and it did it, and that dangling value is lost to oblivion. For the same reason we don't want to use an import inside our functions, we're going to avoid using prints inside your functions. Your function will return the value, and then if you really want that value printed out, print it out after the value has been calculated and returned by the function. So you might say, but it would be so easy if I just wrote a function that gets the input, does the calculation, and prints out the result. Sure, you could do that, but you're starting to create areas for possible bugs and issues to arise. It's better to read the input, call the function with the value that you inputted, get the result, print out the result. Keep the I/O separate from the function calls. Questions about any of that? If this ends up tripping you up, you're remarkably normal. You're remarkably typical for someone learning. And Google Colab doesn't do you any favors with this. It seems to actively try to confuse you. I mean, for me, as an experienced programmer that knows the difference, having that dangling value just printed out, displayed to me, is kind of handy, because sometimes I can be like, what's an ASD? Oh, it's the 68, great. But general purpose programming, it could be a recipe for disaster. Return and print are very different. Return displays something to you, the human, return has the function return a value to whoever called it. Okay. Yeah, collab is misleading. That's what the warning is there. Now here, write this function, another activity, because it's really good to get practice with functions because you're going to be writing a lot of functions. Write a function to calculate Euclidean distance. Takes 4 parameters, x1, y1, x2, y2, and it calculates Euclidean distance. There's the expression for calculating Euclidean distance. If you forgot, you take the difference of the x's and square them, add it to the difference of the y's and square them, and take the square root. That's all. Write that function. But of course, I haven't shown you how to do squared, although you may already know that. And I also haven't shown you how to do square root. But see if you can find out how to do those things. Remember, Google exists. One thing I really like about this one is there are a lot of different ways to code this and get the exact same answer. And they're all correct. Anyone done? Wow, you're quick. I'll wait a minute more, and then we can talk about it. Who here had to look up how to do the squaring something? Did you go to Google, type this in, and see basically this? Isn't this amazing? How do you do it? Oh, just use star star. Oh, okay, cool. That's like the exponent. So power of 2. Who here had to Google how to find the square root of something in Python? Who here typed into Google and found this web page? Yeah, I did. Funnily enough, it shows you how to square. But how to do a square root? Oh, you got to begin by importing math. Oh, okay, I got to import something called math. What's up with that? But then to do it, I just say math.sqrt. Oh, okay, great. So whenever you have a question about how do I do this in Python, throw it into Google, you'll find the answer. Yes?
You go to the power of 1/2.
You can also do that. This, Mr. Tricky over here, huh? Did anyone do it to the power of 0.5? Ah, look at that, show-offs, eh? So let's see, Euclidean distance. I'm going to get fancy. So first, import math. Return math.sqrt of, okay, x1 minus x2 squared plus y1 minus y2 squared. Print 0, 0, 5, 5. Nope, print 0, 0, 5, 5. Oops. There's the distance there. Great. I did it all in one line of code. I'm going to be honest, I mean, there's nothing wrong with doing it on one line of code. Who here did it in a way where they kind of broke it up step by step? Yeah, reasonable thing to do. Did anyone do squaring by just taking like the difference and then multiplying it with itself? No, no one went with the way to do that? That's fine, whatever. Could have done that. You could have done square root with math.square root, or if you want to do it this way, you can do 0.5. Same thing. With doing it that way, you don't even need to import math. That's cool. There are a lot of ways. I could make a variable called like xdiff and calculate the difference, and then use that difference and multiply it with itself, and then add it to the square of the difference of the y's. And then there are so many ways I can do this, and they can all be correct. All right, we'll wrap up here. I'm already going over.